spaceexplr episode. This is episode 65, as you see here, and we have a very interesting guest today. We're going to be talking about satellites, making those available, and we have those discussions about that. So we're going to be covering pros, cons, everything that's going to be related to the satellites today. So if you're interested to hear more, make sure to continue to watch this episode. And today's guest is Dennis Silin. So Dennis is an accomplished software developer and building space entrepreneur. Dennis has the experience, wisdom, and tenacity to push through the obstacles on the path to success. He contributes to the space exploration, including making into the finals of 2016 NASA Space App Challenge, speaking in 2011 NASA DARPA 100 Year Starship Conference, and taking part in ESA space mission since 2019. So his education includes business science, as far as I'm guessing here, and computer science from Ryerson University, and Astronautics and Space Engineering from Cranfield University as well. And of course, the website that you should go and visit, it's called Exodus Orbitals. That's exodusorbitals.com. Of course, that link is going to be included in the show notes, so make sure to go and visit for more information. And of course, Twitter, Instagram, LinkedIn, and the rest of the social media is going to be there. So without further ado, Dennis, really appreciate you coming on today. Thanks for the time.
Hello and welcome everyone. Yes, we have quite a quite a story to tell about what we do, and maybe I can start with sharing my background. And I always had a passion for space exploration, and always wanted to do something in this area. However, joining a space agency or even aerospace company is not an easy path for everyone. And while I did this journey myself, I wanted to make easier for everyone else who will follow in my steps. So this is what I want to talk about. What we're building in our company is called Satellite as a Service. This term comes from the information technology industry, as a service. And the core concept is quite simple. Instead of, letting people build and launch the satellites by themselves, which is very expensive and difficult, enterprise, we will build the satellite and launch it and rent it out to the customers. Basically, think of Airbnb or Uber model for space exploration, where you can rent a real satellite and get access to its instruments, imaging cameras, and get control of the satellite for a certain amount of time. And you will only pay for that amount of time and no more, meaning that for a few $100s, you can absolutely get the same level of access to satellite as NASA or SpaceX. So that's the core concept behind our company business. By building and renting more and more satellites, a lot more people can get direct access to controlling and flying the real satellites in space. And I think it's a pretty cool thing, because right now it's very limited opportunities for everyone in the world to participate and not just observe what other people do, and we definitely want more people to participate.
Definitely. Okay, so can you Dennis, can you talk a little bit about your first mission, the NOVA mission, and can you explain a little bit more in detail on what these satellites are going to look like?
Yes, so actually it's going to be sort of second mission. The first mission was the European Space Agency one, which is testing this concept, the satellite as a service. But let's talk about the NOVA. Well, it's going to be a cubesat, a small satellite, which is the size of a laptop, or approximately this big, and it will have an imaging camera that basically can make photos of Earth in certain specific way, with certain numbers for resolution and spectral bands, which is useful to many Earth observation applications like imagery, like the cartographic applications or pollution monitoring. The thing is, we don't want to do all this application ourselves. We will launch the satellite and provide a software development kit or API for the programmers, so our users, to basically write their own code and upload to NOVA satellite. And that will give them, the full access to the functionality of the satellite. They can take images, they can point the satellite to a specific area, they can process those images on board, and they will get this data through our infrastructure as the outcome of their, software application execution. So think of, the web server, how you rented a virtual machine from the AWS or any other provider, and deploy your code and run your code, and effectively you get the full capabilities of the underlying hardware without the need to pay to install the server and data center. You just rent the time on it. Same concept will work with our satellite. You'll rent the time on our satellite, and that will allow you to deploy your own software and use the satellite platform, satellite hardware in any way you see it fit.
Mm-hmm. And do you have, how many satellites do you have operating currently?
Well, right now, we are basically have access to one satellite. That's the ESA one.
Yep.
And NOVA satellite will be our own satellite, fully our satellite, which we're currently in the process of, building and defining the mission. Mm-hmm. And if things will go well, starting next year, there will be more than just one satellite. The idea is to build large enough constellation so we can take on board every interested developer from all around the world, and have basically a cloud computing in space, to describe it like this, a sort of data center in space kind of infrastructure.
Mm-hmm. So the NOVA is going to be the 3U CubeSat, right? So made of the 3 different parts. So how many different users can access and use the satellite?
Quite a lot, actually, as long as they the schedule can accommodate them, like at least 100 users. They may not be able to run the software at the same time, but they will be able to use it on one after another basis. So one user gets access, runs the code, gets the data, and then after a few days or a few hours, next users come in and so on. Mm-hmm. So it's the model again. This model is being tested by the ESA, this mode of access. So we'll take lessons learned from the ESA mission.
Got it. Okay. So can you take us back to the time? Because I would love to hear that story, man. You having, bachelor's degree in science and, and master's of science as well. But, can you explain how do you pitch your idea, or how do you go about talking with people from ESA? I mean, how do those situations for you personally happen?
To get roll back in time. So I had the idea of basically starting the company back when I was studying for my master's degree. At that time, I didn't know what exactly I wanted to do. I looked into small space launch systems, but the budget was definitely not within my reaches, 20 million to start with. And we tried a few concepts more about satellites, cubesats, but we didn't have a solid idea, a really good one. So after I finished my master's, what I did, and I was in Malta again with my family at the time, I looked into all the upcoming nanosatellite CubeSat missions for the years 2019 to 2023, and I assembled the list of them, which was an 80 pages document, and tried to come up with an idea that was not on this list. So something that hasn't been, included already. So after a while, me and my friends, co-founders of the startup, we looked through this document, and I came up with an idea of why don't we use the same concept as in IT industry and basically create a satellite for AMP. And at that time, I thought this idea wasn't in this list. So I thought, oh, that's something new. And we started to work on this concept, and we worked on that for several months. And I think in May 2019, I decided to review this list, or April, I decided to review this list one more time to see if I didn't miss anything. And I found out that there was a mission exactly like we are trying to develop called OPSSat, the European Space Agency small satellite mission. And well, it was the same thing. So initially, I was very disappointed, thinking, well, my idea is not that you, after all, someone else came up with this concept long time ago, actually. But then I said, what if we try to connect with ESA some way and see if we can collaborate in one way or another. So this is exactly what happened, and one of my teammates found the email of the project manager of that program. And we exchanged emails, and he sent us like the fill out form, and you will be part of the ESA mission as well, which we did. And at that time, I thought, well, this is like the first step in the very long process. I was under impression that participating in an ESA mission is years of work and tons of paperwork. But they had what I didn't know at this time. This was designed a little bit different. So we got invited to the workshop in Darmstadt, where the ESA Space Operations Center is. And me and my other teammate came there, and we were asked to present what we are trying to build, like a software as a service. And we did make a presentation, and we showed it in that workshop. And with that, there was a number of other mission teams, experimenters. And after all this is done, I thought, well, okay, that's nice. Now what's next? And I came up to the project manager and asked him, okay, what's the next step? And he said, there's no next step, you're in. That was it.
Wow.
And this is like that magic moment, that one of those magic moments that do happen in space exploration time. And I was completely like, all out of this world experience, hard to describe how excited I was, and my fellow teammate as well. So the catch was that we had to finish our software development in 2 months by the August of this year. And at that time, our software only existed as 4 pages of PowerPoint presentation. So that was definitely something for me to handle, which I did successful. And yes, that's a story for another day. But yes, in 2 months, our software was ready, and we finished initial testing campaign. The launch got delayed a little bit, but the satellite was launched in 2019 in December, and the launch was successful. And this mission is currently in operations and flying around the Earth. So we are in touch with this and making some progress on our mission results, experiments that's currently going on. And yeah, that's the story how we got into space, and it's a bit of unique experience. Normally things don't happen that fast, but it's also a good example what's possible using this model, satellite for end. Basically, ESA is being the provider and we're being the customer. We're not paying because it's a government agency and being covered by the budgets of the countries members of European Space Agency. But the same concept can be applied to the commercial service. Once the satellite is in orbit, your time to get on board is not years. It can be days or even hours. And this is something that has never been done before, but it's possible now. And while it's not as exciting on surface as maybe SpaceX mission launch, it's still nevertheless a very big deal in space industry. And for everyone who is interested about space exploration, this capability exists now, and you personally can become part of the space mission if you express enough interest. And this is something that we want to offer to everyone on the planet. And it's a whole different story doing something of your own in space compared to just watching things going on TV, on the internet.
Mhm. So coming back to the point, as I mentioned, if we're talking about the testing, can you talk about what type of components are there going to be or currently are using in the satellites, and what type of testing can you do while operating satellite in orbit for the people who will be creating code and using the satellite?
So, well, the concept is simple. In the end, what you get is an access to the satellite onboard computer, and it's like a computer like a laptop or a desktop in the end, and you get access to operating system and underlying hardware functionality. So what you need to do is make sure your code behaves exactly as you expect. And basically the test we have done with ESA is we submitted a test program which was operating the virtual satellite, specifically like to point at on the ground and make photos one of the tests. And this is something we will offer as part of our platform as well. Before, of course, before your code goes into space, it will get tested on the ground. Mm-hmm. And we already have a ground hardware prototype. And as it will mirror the satellite functionality, it will have the attitude control API, it will have camera API, and it will have like a health monitoring underlying middleware that makes sure your program is not misbehaving, and if things will go wrong, it will shut it down. Again, this parts of the technology is already been invented before, and we are just taking lessons learned from the ESA mission to design ours in a very similar manner. As with pretty much software development, any software development project today, before you deploy anything, you basically run the same code on the test server and watch what happens. So there are no surprises in space. The hardware is pretty much similar to the hardware on the ground. It's going to be like an ARM CPU and Linux operating system, so not entirely unfamiliar to the developers who not familiar with space industry hardware. And the imaging camera can be of different types, can be a visible light or infrared or other spectral bands. And other instrument which we want to deploy in space and allow software developers to work with is called software-defined radio. Again, this type of hardware already exists on the ground, and it's quite versatile. You can listen, program it to listen to the FM radio, or you can program to listen to the aircraft traffic controller, and so on and on. It's quite a number of different missions you can do with either the software-defined radio or the imaging camera, which we are also talking to a number of developer teams around the world, explaining what we can offer, and they will get the opportunity to run their ideas on our platform. Again, most of these applications come from Earth observation area, and this is basically what our platform is first and foremost about.
Mm-hmm. So if we can call it the membership, for now, like, can you explain how much would it be and what will be a time frame that you can use a satellite and one of the parts, let's say a camera, and do the testing? Is it going to be like a contract is going to be for a month, or is it going to be for a week? Like how long, the shortest period of time that people can use it and the longest?
Well, the shortest period of time will be 90 minutes, 1 hour and a half. It's one orbital period of a satellite. And it's pretty much pay as you go kind of service. You don't need to sign a contract. You use your same way of subscription plan, or one at a time purchase. You can purchase only 90 minutes, or you can purchase 10 orbits or 100 orbits, so up to an entire year if you're willing to pay for the time on the satellite. And you have on the interface, and you just buy basically those slots. And how much is a good question. We haven't decided on certain fixed price point, but as a starting level, will be like a $500 per orbit. So everyone with, can spare $500 can get at least one orbit in space. We'll change our price depending on demand, on user demand, on availability. We hope to make it, more and more affordable to more people. But this is what you can do. This is what, if you want to purchase time on our satellite right now, we already have the interface on our website where you can just pre-order the time for our Nova mission, which we hope to launch before the end of this year. So we can begin the mission operations as soon as 2021.
Mm-hmm. And you mentioned one thing which I thought is very interesting. You said it's an Airbnb in space, taking Airbnb in space. So, well, at the same time, I'm thinking about if I'll go to the Airbnb, there will be some sort of a contract or something that could make you liable for, any broken items in a house and things like that. So is the end user is going to be liable into, any damage that happens with the software, of course, because probably there is a little bit of unknown, and I know you probably have a thorough kind of process to check the end user and see if the software is going to be compatible, if he can use that and it's going to be safe to use it. But is the end user is going to be liable for any of the damages if they will occur?
At this point, no liabilities for the users. I don't think any of our users can afford a liability if they break our satellite. It's our own risk. Again, like what you said makes valid point. However, our software development kit will be hard to misuse. We will not give direct access to the satellite hardware. It will all go through sufficient amount of indirection and safety controls. So if you do try to do something potentially dangerous, you will get prevented from doing this again as things will get tested on the ground. So your software will get executed on the ground first, and any kind of potentially mission-ending scenarios will be caught on the ground first. That you need to be fully prepared for before we let you run the software in space. Again, this is the hardest part of our technology to solve. However, we will be using ongoing experience with ESA and to design our safety measures, because it's the same problem, the same challenge is for all the users of the European Space Agency satellite, and they have a special kind of safety measures to prevent user programs from destroying the satellite, as well as the satellite is specifically designed to be robust and withstand like user abuse potentially. There are some secret sauce in this kind of technology that we are aware of, and we need to develop it. But yes, in the end, no liabilities for the users. They are free to play within the limits we will set for them.
Got it. So talking about those safety precautions, can you, first of all, can you talk about how long is the satellite mission on its own? Will there be a different time frames? I mean, operating mission, is there a year, 2 years? Like how long does the satellite itself is going to be in the orbit?
So our conservative estimate is a minimum of 1 year in orbit. However, the satellite will operate for longer than that with a good chance of 3 to 5 years mission lifetime. However, the year is the minimal possible time for the satellite in orbit.
Okay. And can we talk about one issue? Because it sounds like, at least from the conversations that I had currently with some people, it sounds like it is a little bit of an issue, and it looks like it could be potentially in the future an issue of space debris. So, but I want to personally kind of understand the way the satellite operates itself. So what about the propulsion system? Do you use like ion propulsion system? What are you currently using for the satellite?
As part of our safety measures, the satellite will not have a propulsion system. Just for you, nothing to hijack for the users, even in the worst possible case scenario. However, the satellite is launched, will be launched into the low Earth orbit, and within the current space debris mitigation, regulations, meaning it will re-enter the Earth and get destroyed in the atmosphere in a few years and not decades. And this is currently what is required of this kind of missions. So if you're familiar with the space debris problem at the orbital altitudes of 500 kilometers or so, same as International Space Station, all satellites don't stay there for too long. They all eventually get slowed down by atmosphere and re-enter. The orbits of say 700 to 800 are the most problematic ones, because the satellite lifetime based on just atmosphere drag is far too long. They will stay there for the hundreds of years. And definitely if we would be launching satellites into those orbits, we would need a deorbit plan to comply with current regulations, which require satellites being deorbited within, I believe, 25 years. But for our mission, for NOAA mission, it's not a problem. It's launched to an orbit that's slow enough, so it will re-enter on its own in a few years.
Mm-hmm. So it seems like you're going to be operating same kind of, altitude as the Starlink.
Yeah, I don't remember the exact numbers, but the Starlink has all those mitigation measures in place as well.
Got it. So what will be for you guys as let's say, if we're going to project the business and the project, let's say 5 years from now, or 10 years from now, what will be kind of the best place and the best case scenario that you want to be in the future? Like, where do you want to be?
So in 5 to 10 years, we hope to have quite a large constellation of Earth observation satellites, which will host all kinds of instruments that are currently being in use for Earth observation missions. And they will be available to our users as either one physical satellite having all the instruments, or as a virtual system with multiple satellites with different instruments combined together and presented as one virtual satellite to our developers in a transparent way. That will require definitely a lot more research and development work, but that's the plan for the near future, 5 to 10 years. So a constellation of satellites with all kinds of functionality. And what we want to go beyond that point is my inspiration was not in satellites. I wanted to build like a large space stations and provide them as in a way that Airbnb provides real estate on Earth. So the long-term vision is the real estate in space. So you can rent a room on the space station, live there as long as you want to, be it a week or a month, like entire lifetime. And that's the very, very long-term vision beyond 5 to 10 years time frame. But I do want to talk about it because it's one thing to operate in satellite. No matter how good it is, you're not in space. And another thing is go there yourself in person. So this is one we also want to build, a real Airbnb in space where you can live there and explore the universe as much as you can. But that's definitely in our plans as well.
I love that. So I love that idea. Well, it sounds very appealing, and I think there's all these different private companies. There's a lot of those coming up right now, and they're looking for these type of services, if we can call them, at the same time, and making, as one of the previous guests saying, space is now open for business. So definitely Airbnb and having those type of experiences, like sleeping, waking up in the morning, and instead of you see an ocean and a beach, you actually see an Earth, which is it's a completely different experience. So can you talk about that? I mean, first of all, why we as people need to go and explore the space? I mean, why is this personally for us should be important?
I'll try to explain in sort of the most rational manner possible, like less maybe poetic and more directly explaining the value. So Earth as a planet is sort of bounded world. It's only so big. There's only so many people that can fit on that. So many things we can do, It's a sphere of fixed radius. However, the space beyond Earth is effectively unbounded. There are no limits what you can do there. If the idea for why we should go into space is basically expand all the range of our activities beyond, from Earth and into the outer space, extending our economy and extending our living quarters, just like we expanded into all the places on Earth, starting from Africa and going to Europe, Asia, and New World. The same approach, we should continue and extend our presence into space as a matter of both survival of our species and the matter of growing our economy and making the human civilization more affluent. As I mentioned, space is effectively unbounded, and that means it's unbounded in an amount of resources we can access, like asteroid mining or other planets, amount of energy we can harvest from sun and every other star in the universe, and literally like physical space. Like if you look at the surface of the Earth right now, it's already divided between all the countries. There's no new unclaimed land, but the entire interplanetary space is effectively unclaimed space. So if you want to go and start your own country or your own city or your own culture, the space explorations presents you this unique opportunity that you cannot find anywhere on Earth. Like I want to start my own empire. If I want to do it on Earth, that's not definitely fly well with United Nations or other countries. But I'm free to do pretty much anything as soon as I leave our planet and expand. This is what the end goal of both our company and I think the humans on Earth. Imagine like every single person gets an opportunity to unlimited growth or unlimited self-expression. This is what space exploration offers in the long run. While not everything is possible right now, in 5 to 10 years, things will change, and things will change even further in 20 to 30 years. And it's still, this time frame is still within your and mine lifetime. So we should prepare for that now, and we should explore these opportunities when the time comes. This is why we need to go into space, in my opinion.
Got it. Well, it makes a lot of sense. So if we talk, like you mentioned, the change. So what type of change do we currently need, and what components are we missing from making that happen? 10 years from now. Like what is missing for now?
So one and most obvious component is the cost of access to space. Now, like thankfully, this is not all on my shoulders. My fellow entrepreneur Elon Musk is working hard to make space a lot more accessible. The cost of literally the cost of kilogram of mass per orbit at this very moment is out of reach for everyone's pockets pretty much. With the SpaceX Starship launch system is going to drop a lot, and we kind of bypass this limitation in our business model because software has zero mass. That means the marginal cost to get it into space is very low, literally like dollars instead of tens of thousands. So one component is currently missing, and that everyone pretty much understands it needs to be solved, is the cost of space launch. And again, there's quite a number of companies, not just SpaceX, that are working hard to reduce this cost. And once this happens, now you have like a playground is open, and now there will be an opportunity for people. Wow, okay, the cost of space access is low now. Now, what can we build with this kind of opportunity? And this is where my part comes to a picture. Provided there will be a number of users who will already be familiar with the model of rental of space access, space assets. We will build and launch a lot more stuff and let people play with it. What they will build with capabilities, I don't know. and fundamentally it's up to them. It's one thing to have a satellite you can play with. Another thing, what if you have like a space station to play on? And this is the opportunity that also needs to be built. Like space is mostly empty in terms of its infrastructure. We have just one space station that can host, just 6 or 7 people. And that's definitely not enough capability. Now, if we can build a lot more space stations, a lot larger space stations around every planet in solar system, around the moon and the Mars, with hundreds and thousands of people able to access them, that by extension, by definition, will create a space economy, will create a place for people to do things, create something, run activities. There are quite a lot of things you can do only in space. But for those things to happen, you need both the people there and the infrastructure there. So this is like the second step beyond making access to space cheap. Now you need to build infrastructure. And again, I'm not the only person who understands this part. If you look into the plans for lunar gateway, it's basically a space station around moon. It is an infrastructure. If you look at many of the space startups, they're talking refueling stations in space or asteroid mining in space. Again, this is infrastructure that needs to be built, like ports and roads, the same thing that happened on Earth. When people come to the UN, there's literally nothing there. So they built cities, they built roads, they built factories, and all of that needs to happen on the scale of solar system. Again, once a Starship flies reliably, that means you can launch millions of tons of goods and equipment and send people. So you can literally start building up the interplanetary space. So this is the second step. And once that happens, as more and more people will be living in space, you can start think of getting independence from Earth. Once you have self-sustaining habitats, once you have an independent source of energy and resources like asteroid mining or moon mining facilities, you can start thinking about, wait, we don't need to be an extension of any of the Earth cultures. We can build our own independent country in space or independent city in space. And that's an opportunity as well. People want to live in the way that was not previously possible on Earth, or they want to have their own independent statehood. And again, this is sort of far in the future, but not so far we cannot plan for this right now. This is sort of number 3. After the infrastructure comes the self-sufficiency and independence. And once this happens, well, pretty much all bets are off. It will become hard to predict what's going to happen if 8 billion people on Earth will get an opportunity to leave Earth and live in space, in any of those space cities. Fundamentally, it's what I long-term vision, expanding beyond Earth, and there's no limit how far you can expand. And of course, you cannot go to Alpha Centauri on day 1, but you can go to Moon in this decade, to Mars maybe the next decade, other planets before the end of the century, and on and on and on. So it will be hundreds of years of expansion and exploration in front of us. And I think that's a great opportunity. And the best part, you can already start doing something of this right now in this very moment.
Got it. So what do you personally think about this, this idea of, people just not wanting to explore and not wanting to be part of the space? Because I'm sure there will be a few people who would say, even though your service, let's say for now or for the future, like $500 for a lot of people probably doesn't sound like a lot of money. For somebody will, and some of the people would say, listen, yeah, I want to go and use the satellite, and some people would say, no, I don't want to use it. So the same people would say, yes, I want to go and use and stay in this kind of space Airbnb and pay the money, and other people probably even more than, using space, using the satellite that you have, they will say no. So what do you personally think? I mean, because technology is one thing, but are we ready for those, breakthrough moments in space and creating space stations and colonizing different planets? Are we ready, like mentally, as people right now for that?
I have a good story to back it, but my point is the first half of my answer is basically you leave those people like alone, like you let them do what they want. But no one is forced to do anything they don't like. Like it's fine. Some people will stay on Earth and live all their life on Earth, and that's fine with me. Again, it's an opportunity and not a mandatory thing.
Hmm.
And the second part about being ready or not ready, you're never ready until you actually do it. So with my history of my company, I was never feeling like ready. I was rather the opposite. I was feeling like it's a bit too much for me to do. But you will never know if you're ready or not until you try. So there's never a moment when you feel ready. It's either in your future or already in your past. And looking back, you can say I was ready, but you cannot say I am ready now because you simply don't know that until you actually start doing that. And you are becoming ready to do this stuff by doing the stuff. There's no way to predict it, or no way to plan for everything. You either try it and learn, or never try it, and you will never know if you're ready or not. Sort of, you need to do it regardless of how you feel about it, if you really want it. That's my answer. So
That's a
okay,
very
yes,
good.
so yes, humanity is not ready, but we have to do it to become ready for our space exploration, for the future of our space exploration.
Got it. So do it regardless of the way you feel. That's what I got. I had that note here for myself, and I think it's a good note to keep for everybody because it's definitely true, and it could be applicable here on the planet while we're here still. Because you just sometimes have to do it because there is probably multiple factors that will come your way, and you will have multiple excuses at the same time to say no, I don't want to do it because just the feeling that you have. So, and feeling is what? It's just an emotion that your brain creates to protect you from whatever you want to do. That could be important. So, do you plan? Do you actually? Because like I love the fact that we are looking to create a moon base and colonize, Mars. People talking about a lot. So, do you see that happening? Because the problem I think with the people and especially with the younger generation is a lot of these projects, especially if it's coming again from space agencies like NASA or ESA or JAXA or any sort, like the problem is it's a long process and it takes a lot of time. We're talking about 4 years, maybe 5 years planning in advance, and of course there's a lot of different moving pieces. It's not that easy. It's billions of dollars, so we need to kind of understand, if they're gonna get the money, because it's a tough process, right? And you kind of know yourself because you've been going through a similar type of thing. But do you think, again, it could be done quicker? We're talking about 20 years, 40 years, because again, the younger generation, because of the social media and what's happening with this digital age, we just somehow don't have the patience.
Yeah, I'm not exactly that old, so maybe I am part of that generation as well. So yes, it does take a lot of time, but a the whole mm, gist of our company is getting things done quickly and on a small budget. We start with satellites, with small satellite first, but we plan to scale up and continue to maintain this approach. So whatever we will do will be affordable to everyone, or vast majority of the younger generation. The second thing, I do have a lot of hope for the private space flight industry. Definitely they can do things much faster and on a smaller budget than space agencies like NASA or ESA. And the last thing, even 5 to 10 years is not a lot of time. If you are choosing space, aerospace as a career choice, you have to be prepared to be there. It's a long run for the long ride. It's not like you can build a spaceship in a few weeks. However, with our approach, the speed of space exploration, in our case, is defined by the software development, and not so much by the hardware. And software can definitely move fast. So, as an example, I'll give you our software for the ESA mission was completed in just 2 months, from 0 to passing the test at ESA, with ESA. So if you are a software developer and you are interested in space exploration and you are of the younger generation, I can assure you, you will get your code deployed to space in a matter of months and not years. If you do think of building something physical in space, that will definitely take longer. However, the speed of space exploration is accelerating. People have been talking about going to Moon and Mars for decades, but only in the recent few years things have picked up. If you think of the Lunar Gateway, they plan to launch the first module in 2024, and that's about 4 years from now, which is not a lot. And if you look at the other projects, things are finally have been speeding up to a point where it's under 10 years. And if you're a young person, 10 years is nothing. You will still be a young person in 10 years. So yes, there is enough improvement. So I do recommend people to look into joining the space industry and look into going more. Well, it's whatever opportunities available to them. But space sector as a whole is undergoing a growth phase finally. After many decades of being stagnant, there is now enough traction, I can say with confidence, that there will be more and more projects going on that many of the people can join, many of the younger generation can join and see the results within their lifetimes, and even not within decades. Under 10 years is definitely an option for many of the projects that are currently going on. Again, with the moon exploration and low Earth orbit exploration, things are moving pretty fast. So yes, that's things are getting better now.
Got it. So what do you personally think about using AI or applying robotics into kind of our day-to-day lives, and again in space science and space industries? Do you think it's a good thing? Should it be done quicker? I mean, how important is AI to our future lives overall? What do you think?
Well, I'm not an expert in AI or space robotics. I do know it's a very important part of the space industry, and with many missions currently rely on the being autonomous beyond the human control, and basically space robots doing things on their own. So that's definitely an area to grow. However, I do want to note that the best results currently are possible when AI and humans are combined. So with all the space missions in beyond Earth, while many of the spacecraft are better at being autonomous, they still depend a lot on support from the human controllers. So I don't see that space robotics will be a solution for everything. If anything, more space robots will require more human presence in both building the hardware and supporting the remote operations. It's an opportunity. It's an opportunity to participate. I personally want to see more human activity in space. I don't want to see our civilization to depend exclusively on the AI or space robotics in space. This is something I prefer to have people having hands-on instead of just outsourcing everything to computers. And it's just ignoring all the economics. It just feels different when you have your personal your own experience doing things and not just observing a space robot doing things for you. It's a part of our human nature to explore and touch and do things. I don't think we should leave everything to an AI to do for us.
Exactly. I think I would be on the same page here because even though we have important missions, like just like Perseverance, which is going to be landing on Mars in February this year, and we're looking forward to that because the Perseverance is going to be doing some groundbreaking through research and looking for evidence of some sort of a extraterrestrial bacterial life on Mars, and it's very good that we have those things going on, but it seems like we have, again, with the distance of just 7 months of traveling to Mars, we should have somebody there already, probably, because again, the technology is definitely there. And of course, there will be always some risks, and we probably cannot mitigate all of them at the same time because there's just unknown factors ahead of us. So we just have to sometimes, it's crazy, as bad as it sounds, sometimes we just have to pay the price. If something happens, that means that's the price. Look, there's people dying every single day on the planet with no reason, from starving, from some sort of earthquakes, volcanoes, like just drowning, like a lot of different things are happening while we're talking. So why not send a group of people or just the people there and kind of explore and make this process faster, because that's kind of the key, to make everything faster, because everything is just taking too long. 50 years since the last we've been on the moon, and people are just frustrated a little bit with that. So
Totally. The people, if you go to mountaineering, try to climb the Everest or any of the other 8,000ers, the fatality rate there is quite high, but people were willing to accept that just for the sake of experiencing that part of human life. Just climbing up the mountain is a risky affair, but people do it anyway. And like safe space exploration, human space exploration is a lot safer activity with preparation and planning. I don't think it will be that much of a risk for the astronauts on the moon or even on the Mars. So we definitely should go there, and more people should go in space. It is an unbounded frontier, which is hard to imagine what will become possible in 100 years. So beyond that, definitely unbounded opportunities out there.
And what do you personally see? I mean, from this kind of outbounding view, still untouched, territories, do you think, and what do you personally see from kind of political sides? So do you see the space is getting more accessible and kind of the laws are getting lesser and lesser when it comes to control? Or do you think there should be more control in space and orbit, and once we're going to go and kind of try to live in different planets? Or should be less kind of laws and regulations with that?
Well, I'm definitely on the point there should be less laws and regulations. However, if enough people go beyond the reach of the terrestrial governments, there simply will be no point in enforcing, making those laws if you can't enforce them. I do think that, initial stage of solar system colonization will be a lot of like Wild West, with the not necessarily rule of the law, but rule of the who is the stronger there, and that might cause quite a number of conflicts. However, the benefits of what can be done, provided unrestricted access to space, are a lot more than the risks. So less regulations is usually better for innovation compared to major industry like healthcare or aerospace and defense right now in many areas, which is so regulated that's really impossible for an outsider to make an innovation and make a breakthrough in 1 year, which is a bit of a problem. If we want to get things done, we do need to loosen some restrictions, specifically in space exploration, and just in general in other industries the amount of innovation done is almost proportional to the amount of, people trying different things. And if they cannot try due to regulation barriers, there will be no innovation pretty much. So the same approach, I think, covers the space exploration. If we want to have, multiple space cities, there should be no laws banning creating them, because either people will ignore it and do things on their own, or if it's going to be so hard, then such an amazing things will never happen. So in my opinion, less regulations is better.
Yeah. So definitely, because yeah, there's a lot when it comes to regulations and rules. Because we created, because now we're just running like this hamster in a wheel, all the time here on the planet. Because we just stuck again with our rules and regulations, which, as you mentioned, it's a great point. It doesn't allow the innovation to go fast enough, because we definitely need that. And but it's just a question of when and how, and most of the time it's, of course, it will come through private companies just like SpaceX or other your industry, and with your company for the future, because we need more of these public people getting involved with these projects. So on that note, I mean, what would you say to the people, the ones who are actually, they would like to go and stay in space station, space Airbnb, or go and visit different planets, and not for those who want to stay here on the planet and live the lives that they want? What would you say for those people who want to continue to explore? I mean, is there some sort of a ways or a process that we can prepare for those moments once we can have an access to the space? Like, is there some sort of a mental shift that we need to make and understand something that we don't understand right now? Like, what will be kind of the process that we have to go through?
As I think I mentioned before, you cannot prepare for those things. You cannot feel ready until you actually try them. So the only thing I can say is just go. If you get the opportunity to leave our planet and try explore the universe, explore the solar system, or you get an opportunity to live in space and build your own independent culture, the only thing I can say, just go and do it. It's very difficult to predict what's going to happen, and it's a good thing. It's a great thing, because with unbounded opportunities comes unbounded possibilities, or rather the opposite. With unbounded possibilities, there will be unbounded opportunity. You have to go and build what you want to do, and it's not so easy right now, but it will get easier as we go in through the 21st century. And right now, I can offer you the first step: build your own thing in terms of software, code, with our platform, with our Exodus Orbital satellite as a service. I think that's step number one. And if things go well, there will be step number 2 and number 3 and so on. I don't think I need to state more. Space is an opportunity for everyone, and it's a great thing to be part of the space exploration efforts. While our current company is small and not that famous, we are on the right track to expand. We are on the right track to grow, and there will be more opportunities we'll be offering to our clients. So I do invite everyone to join us in this journey and have a look at our website, exodusorbitals.com. And you can already start preparing for our first mission that will happen this year. So things are going pretty fast in terms of time. There's no need to wait 10 years before you get this opportunity from us.
Exactly. And as you see here, Dennis is a true explorer, because for him is very simple. It's we just need to go, and that's what explorers do. They just say, okay, let's go and let's figure out on the way where we're going to be there. So I think that's a good kind of thought process, instead of thinking too much. And of course, there is a lot of different factors that we need to think to kind of mitigate the risk, but we just have to go. So I love that. I love that. So guys and girls, so make sure to go to exodusorbitals.com again for more information if you're looking to get access to Dennis, satellites and use them again for the testing, while being in orbit. Go and search it out for a little bit more information, or you can get in contact with them on Twitter, Instagram, and on LinkedIn. All of those links are, as always, are going to be in the show notes. And last thing that, guys, as always, I want to ask you, if you share this episode to your friends, it will be super helpful, because we will help to spread the message, first of all, that we need to go and explore the space, and we need to think different, which, again, I love Dennis, your personal kind of thought process and the way you look at things is very kind of simple, very easy to understand. I think that's how people should look at space and space exploration.
Thanks a lot for giving me time to express my my ideas, and hope to continue our journey this year.
Exactly, indeed. So I wish you a lot of great success, because I know you guys, as I mentioned, you're on the right track. So hopefully, people who are watching here, they would like to use your service, or maybe there are some people who would like to add value to a company, because at the same time is making those collaborations, making things happen faster. So again, guys, make those connections, make those collaborations, and just continue to explore. So I'll see you in the next time, guys. Thanks for watching.